Welcome to this earthquake preview and review. It's going to be more of a review for the test. Now in the past I've had a review for each learning target. Well, here I'm just going to have one review. It's for both learning targets 1 and 2. Both of these are strictly on earthquake. I suppose technically the entire unit is on earthquakes and volcanoes, but I'm only going to be testing you on earthquakes before the holiday break. So when we look at a picture like this, are you able to look at a picture like this and are you able to figure out what's the epicenter, what's the fault, and what's the focus? So number one is the location on the surface above the focus. So what do you think that one would be? If you said the epicenter, you are correct. There we go, epicenter. Now, so that's right here, directly above where the earthquake happens. Now, where the earthquake actually happens, or where it occurs, that is your focus, and these cracks in the Earth's crust are called faults. Another big thing you're really going to want to know for the test is you're going to want to be able to tell the difference between a normal fault, a reverse fault, and a strike-slip fault. And when you did the Schoology, and again, the Schoology would be a good thing to review. You can also go through these. Know everything there is to know about a normal fault, a reverse fault, and a strike-slip fault. So what we're going to do is we're just going to pull something out up here and tell me what it is. San Andreas Fault. If you said that's a strike-slip, excellent, excellent. The Himalaya Mountains are a reverse fault. And if you want to pause the video and try and figure these out before I do, feel free to do that. It's more of a challenge for you. How about this one? Rocks on either side of the fault boundary move past each other without much upward or downward. If you said strike-slip, you're right. Rocks above the fault move downward in relationship to the rocks below the fault. So the rocks above the fault move downward in relation to the rocks below the fault. Let's put that under normal fault, and you'll see the differences later. Rocks above the fault are forced up and over the rocks. That is the opposite of this one right up here, and this would be a reverse fault. So think about it. Look at the picture. One side of the fault gets forced up and over the rock. So just read it. Rocks above the fault surface are forced up and over. This is the only picture that shows that. So if you just read, you should be able to get this. A shearing force, if you said that is a strike-slip, you're right. This kind of fault occurs at convergent plate boundaries. Convergent plate boundaries are where plates come together. Excellent. So it's got to be the reverse fault. Look at the arrows. This kind of fault occurs at divergent plate boundaries. Again, look at the arrows. And this is all from our plate tectonics unit. So there is a connection between the two units. This kind of fault occurs at transform fault boundaries. I'm going to kind of slide this right up here. And what's another one? Compression forces. Well, if you press on something, you're pressing it together. So these two plates are pressing on each other. So it's a reverse fault. And then obviously tensions. Remember we talked about a rubber band where rubber band's pulling apart and that creates your tension. So how did you do on those? If you know those are all on LT1 of the test. If you can do that, you're going to do pretty good on the test. But there is a lot to know there. One of the other things you're going to want to know is about the different types of waves that there are, seismic waves. And there's 4 main types. Now, body waves travel through the body of the Earth. So which one is this one talking about? It's the fastest wave, can penetrate rocks and liquids. It's the least destructive wave, can travel about 5 miles per second. If you said, oh, that sounds like the P wave, you're right. So it's the P wave or the primary wave. Sometimes it's called a pressure wave. Another type of body wave is this type of wave. It's the slower of the two. It comes in second. It cannot go through liquids. This is the big ones. It's slower, but it does not travel through liquids. If you said secondary waves, exactly. Sometimes called the S wave or the shear wave. Now, those are the 2 body waves. The next 2 waves travel mainly on the surface of the Earth. So which one do you think this one is? Do you remember this picture from the original video? It's the fastest surface wave. If you said the love wave or the L wave, good job. And then the last type of wave, this is where most of the shaking felt from an earthquake is due to this type of wave. It can be much larger than the other waves and can travel at about 1.9 meters per second, or miles per second, sorry. Can you name that wave? It's the last wave we haven't talked about. It's the Raleigh wave. Oop, that must be underneath there too. So can you tell the difference between the different types of waves? And we're going to have some true and false questions and some short answer ones that'll help you with that. So let's see how you do on these. These are all true and false. There's probably going to be some true and false questions on the test. S waves can travel through solids and liquids. Do you remember the answer to this? You should say false. They cannot travel through liquids. There are 4 waves that are associated with earthquakes. That's true. If the P, S, and surface waves arrive almost simultaneously, the seismic recording station is close to the epicenter. If you remember from our working class, this would be true, because we talked about how the P wave's faster than the S wave, so the longer, the farther away the earthquake epicenter is, the longer or the greater the distance is between the P and the S wave. By noting the change in speed in the reflection point of seismic waves, scientists have been able to determine the structure of the Earth's interior. That is true. And a lot of you have asked that great question. How do we know what the inside of the Earth is like if we've never been there? It's mainly due to seismic waves. Here we go. Most earthquakes occur along what? Let me pull out a pen quick. What color do you guys like? Let's go with purple today. So most earthquakes occur along. And whenever you have multiple choice questions, look at which ones don't make sense. For example, river makes no sense. So volcanoes are faults. Now a lot of earthquakes happen on faults, but along kind of gives it away. It's faults. Seismic waves move outward from the blank, which is usually deep underground. That is your focus. Remember, the focus is where the earthquake happens. Directly above it is the epicenter. What are the smaller magnitude quakes that follow a major earthquake? Aftershocks. And one of the things I will need to explain just a little bit, sometimes aftershocks are larger than the original. And that's sometimes is a little hard to understand, because maybe the other ones were foreshocks or they happened, pre-major earthquake. But some aftershocks are as large, maybe even larger than the original earthquake. At least blank seismographs are needed to locate the epicenter of the earthquake. Hopefully all of you will get this right, because we spent a lot of time in class working on this. Hawaii is volcanic due to its location on a hot spot. That's not on this test. Must be an old review, but that'll be on the next volcano test. S waves do not travel through the outer core because it is a liquid. Remember, S waves right here don't travel through liquids. So let's move to the next page and see where we're at. Now, there is going to be one short answer question on this part of the test, and it's right here. Explain why it's necessary to use 3 seismographs to locate the epicenter of an earthquake. That's not going to be on this part of the test, but you should be able to explain this one. But how about this one? Explain the geological forces scientists believe cause plate tectonics to move. And this is where you need to talk about the convection currents. Remember we talked about those? Let me write it down, convection currents. I'm going to draw down here. So remember we have the Earth and these convection currents. Magma is heated deep within the Earth and it's moving upwards. Now it can't just drop straight back down, so it goes off into these different directions. Let me draw that. I'm going to draw some arrows in here. And it's these parts where the plates are moving away. And if you have another convection current coming here and coming down, this is where 2 plates will come together. And this is what scientists believe is the main reason why the plates move. There's other theories out there like the ridge push slab pull theory, which we won't get into. But a lot of scientists will say it might even work in conjunction with convection currents as well as the ridge push slab pull theory. So be able to answer this question on the test. So here's some more true and false. P waves can travel through solids and liquids. That's true. It's the S waves that can't. Unconsolidated water, saturated soils, or sediments provide good foundation material for buildings and other structures. Unconsolidated. That's false. We just had a whole liquefaction lab. Earthquakes only happen west of the mountains. No, 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 no. Remember we talked about this? We've actually had earthquakes in Wisconsin. And one of the bigger ones to happen to the west of the Rockies, well, and they've been having some in Oklahoma too. But if you remember, about a year and a half ago, there was one in Washington, D.C., a big earthquake, or is centered out there on the East Coast somewhere. So, these are the answers from the thing from above. So if you want to just go to this part, I'm going to move this up a little bit. If you just want to come to this part of the video and review quickly, maybe a second time, and I would even watch these videos 2-3 times to make sure you have it down. So can you tell me the different types of faults? Do you recognize this type of fault? If you said it's a normal fault, sometimes it's called a vertical or a dip slip fault. You're right. How about this type of fault? Or this is where the normal fault occurs, I'm sorry. And it creates a tension force. Happens on divergent plate boundaries. Examples, mid-ocean ridges, Sierra Nevadas are all good locations for it. Here, how about some vocabulary? So what I would suggest you do is maybe pause the video right now and see if you can answer these, and then I'll go through and explain them and see if you get the same answers as me. A point just before the rock breaks. Well, that's the elastic limit. Remember, it's kind of like rubber band. If you're pulling on that rubber band, you're stretching it, and all of a sudden, snap, and it goes. Tension forces create this fault. Okay, this fault. So you know it's a fault. Tension forces being pulled apart. So what type of fault? If you said a normal fault, you're right. Because remember, a normal fault are being pulled, or the plates are moving apart. Movement of the Earth's crust. Now here's another tip when you're doing things like this. If you ever get to one, let's say I don't know what this one is. Just skip it for now and go to the next one. Compression forces create this fault. Compression forces is a reverse fault. Shear forces create this fault. That's your strike slip. Vibrations in the earth that occur are called, I'm going to read the rest of this, that occur after the initial earthquake, which is a good lesson. I almost messed up because I didn't read after the initial earthquake. These are aftershocks. So movement of the Earth's crust is an earthquake. So how did you do? If I hit check, got them all right. So make sure if you can't figure out one at first, skip it for now and then always come back to it. That's just a tip for you. How about this one? Seismic sea waves is a tsunami. Seismic waves that pass through the earth. Body waves. Point on the Earth's surface directly above the origin of an earthquake. That's your epicenter. Point where an earthquake energy is released below the surface is your focus. Instrument used to record seismic waves is a seismograph. Used to measure magnitude is the Richter scale. Seismic waves that travel along the Earth's surface, surface waves. So again, use those textual clues to help you out. So reading is really important. So how'd you do on this one? Would you have gotten them all right? How about this one right here? So I'm going to pick up a pen again, and I'm going to work through this. Let's go with green this time. Most of the destruction during an earthquake is caused by surface waves. Seismologists use the blank to compare magnitudes of earthquakes. Now they're going to use the Richter scale to compare. The seismograph records the waves, but the Richter scale will compare them. The slowest seismic waves are, think about it, primary or surface waves. Do you know which one that is? Remember, the primary waves or the P waves are the fastest waves. So the slowest one are going to be your surface waves. Primary waves arrive at a seismograph station first. They're the fastest. Scientists use triangulation method to locate an earthquake's, what do you think? They're actually interested in the epicenter. Now, it's nice to know where the focus occurred, but typically the focus occurs right below the epicenter. When the building of a stress in the Earth's crust is so great that the rocks reach their blank, an earthquake occurs. That's their elastic limit. So we got a couple more slides on vocab. Let's see how you do. So let's just start in the middle. Sea waves generated by, well, this is tsunami. Oop, let me get rid of that pen. That's a tsunami. So this is kind of a review of some of the other stuff, but there's some new ones in here. The most destructive seismic wave. Again, now let's pretend I don't know that for now. So let's just skip it. Let's just do the ones I know for sure. I know what the lithosphere is. Remember what that is? How about the second seismic wave to... Let me delete that. Second seismic wave to come in. If you said secondary or S wave, you're right. Okay, let's go. The least destructive occurs in the asthenosphere, acts as a driving force. That's going to be your convection currents. Point where energy is released below the surface. That's your focus. So I'm just focusing on the words I know. Okay, part of the Earth that is broken into plates. Ooh, the lithospheric plates. The third seismic wave to reach you in an earthquake. The least destructive seismic wave is the P wave. Okay, so now we have the love wave and a Raleigh wave, the R wave and the L wave. So the most destructive earthquake wave, I'm going to put that one right here. And I'm going to put the L wave right here. And let's see how we did. Well done. Now, what did I remember about the R wave? I remembered that it's the most destructive. And the third seismic wave to reach you is the L wave. So how did you do? So we got one more set of vocab words to go through. So again, pause, see if you can get them, and then listen to what I have to say. So, San Andreas Fault is the one. If you said it's a strike slip, you're right. Compression forces is a reverse fault. Dip slip is another name for normal, because remember one side dips down or slips down. Divergent plate boundary is your normal fault because it's moving apart. And if it's moving apart, it creates a tension force. Strike slip is your transform fault boundary, which creates shear forces. Okay, reverse faults, you have the Himalayas, and you have the convergent plate boundaries. Now, do you remember the Sierra Nevadas and what they were? What do you think they are? Do you think they're the normal fault? Should we check? Yep, they are the normal fault. So, if you have any questions or concerns, what I would suggest, and I'm going to hopefully suggest in class for you, remember, watch this video several days before we actually have the test. Then you can ask questions in class, and I would maybe even watch it a second time or go through Schoology. But study, study, study. Thanks. Bye.